Hello everyone, I'm Josh Bond and this video is a brief look at development operations or DevOps. This video assumes you have a basic knowledge of agile principles. Now, we cannot cover DevOps thoroughly in a 10-minute video, but the goal is for you to develop a starting point in your understanding of DevOps. There's not an agreed upon universal definition of DevOps. Companies pick and choose what DevOps practices make sense to them. But looking at the definitions on the slide, I emphasize the most important parts of each definition. Namely, DevOps is about a team approach between development and operations that extends past the traditional software release. And DevOps uses automation to construct a software delivery pipeline into production. This does not mean that everyone is suddenly a system admin or a network engineer. It does mean that the more automated operations becomes, the further traditional software development can push code into production. Instead of development focusing only on software and operations focusing only on infrastructure, the team focuses on the system as a whole, which includes the software and the infrastructure. Traditionally, corporations have used a silo approach where development is walled off or a separate silo from operations and quality assurance. Operations handles everything that happens after the software is created. Of course, development creates the software, and in the traditional waterfall configuration, quality assurance checks the software. The goal of DevOps is to combine these three silos into one cross-functional team that develops, tests, integrates, and delivers. One way of looking at DevOps is that it's the application of agile principles beyond the software itself to the delivery, integration, and infrastructure. DevOps seeks to do to the entire software development lifecycle what Agile does for software development. Many companies place DevOps engineers within the Agile team. Others view DevOps engineers as facilitators of the automated delivery or deployment process. Most Agile frameworks acknowledge the us versus them mentality involved with separate development and quality assurance silos. Most Agile frameworks want quality assurance to be a part of development to avoid the QA bottleneck. This is where development throws code over the wall and says, okay, we created it, now you test it. The development team waits for QA and then the code bounces back and forth. This creates continuity problems because the wall is the bottleneck. Like most Agile frameworks, DevOps also wants to remove the wall or silos that separate development and QA. This is not an idea unique to DevOps, but DevOps assumes that development and QA are one team. For a number of years now, merging QA with development has been a guiding Agile principle in many frameworks. But in recent years, the industry began to take notice of another wall. We removed one wall between development and QA, but we're still throwing code over a different wall. This is the wall that separates development from operations. This is why many consider DevOps to be a continuation of Agile principles beyond the traditional definition of software development. What if a developer was responsible for shepherding their features into production? DevOps engineers would help facilitate the process, but what if we had this mentality? We code it, we test it, we integrate it, we deploy it, we own it. If there's a problem, we deal with it. It's not someone else's issue. It may sound like a fairy tale, but this is quite possible by building an automated software delivery pipeline that bridges the gap between development and operations. DevOps accomplishes this through continuous delivery and infrastructure as code. Continuous delivery assumes continuous integration is in place. Continuous integration refers to programmers who regularly merge their code into the shared mainline or trunk of the version control repository. A thorough explanation of version control is beyond the scope of this video. However, understand that the main branch is the official source code and developers check out code into their own branches. They work on the code and eventually they merge those changes back into the main line. Continuous integration encourages programmers to commit code to the main line many times per day. By decreasing the scope of branches to the feature level, commits can happen more frequently. These changes are verified by an automated build and test system to keep the main trunk clean. Automated testing includes unit testing, functional testing, and regression testing. When a build fails, the developer immediately knows. Bugs are found faster before they spiral out of control. By merging more often, code is kept in a releasable state. Continuous delivery builds on continuous integration. By automatically building, testing, configuring, and deploying code to the production staging area. Continuous delivery builds an automated software delivery pipeline into production. This means we're no longer releasing software in large traditional lifecycle releases. Instead, we're continuously delivering features or portions of features. Testing in production includes integration testing, load testing, and user acceptance testing. It's commonly accepted that you've achieved continuous delivery when the software can be deployed from the staging area into production at any time without anyone worrying what will happen. Sometimes you hear the term continuous deployment as opposed to continuous delivery. The difference is that continuous delivery needs a final OK to push the code into production. Continuous deployment automatically pushes the code into production on a regular basis without any further approval. Facebook is one of the most famous examples. Etsy is another example, deploying over 50 times per day. Think about what we're really doing from an agile perspective when it comes to continuous integration and continuous delivery. We're just taking traditionally large events and making them smaller. The more time we wait before integrating code, or the more time we wait before another release, the more problems we're going to have because of the number of changes at one time. By working with smaller chunks of code, many times at the feature level, we make climbing the stairs easier. It's a form of incremental development that extends beyond the development environment into operations. Continuous integration and continuous delivery is the goal, but what about the infrastructure to support the pipeline? This is where infrastructure as code helps combine development and operations into DevOps. Infrastructure as code brings software development practices to operations by automatically provisioning and configuring servers and other resources. These resources could be a physical server, hardware devices, a virtual machine, a container, and so on. DevOps assumes that all technology infrastructure can be controlled through code. Code is preferred instead of manual configuration. Standardized environments generated from code are preferred over Snowflake or one-of-a-kind environments that someone must manually set up at, say, 2 a.m. to bring a system back online. In this sense, infrastructure as code automates the tedious manual portion of infrastructure setup. The resulting code should be managed in a version control system, just like traditional software development code. The code and scripts serve as documentation for the hardware and infrastructure, which can be used by developers and DevOps engineers alike. The configuration process is reproducible and portable. Changes in infrastructure are linked to application requirements changes so that it all can be easily inspected and tracked. Since infrastructure provisioning is now a matter of code, development can test applications in production-like environments earlier in the software development lifecycle. We've looked at how DevOps is about the combination of development and operations. We've shown how the distinction between development and operation blurs as a company seeks a whole team approach. This requires sharing of tasks and responsibilities that were traditionally performed by separate people in separate departments, many times reporting to a different chain of command. Can you think of a corporate situation where DevOps could run afoul of U.S. federal law? I'll give you 5 seconds to think about this, or you can pause the video. In 2002, Congress passed the Sarbanes-Oxley Act, or SOX Act. This legislation was designed to prevent fraudulent activities that ended companies like Enron and WorldCom. Portions of this law apply to public companies, especially companies in the financial sector. As it applies to DevOps, SOX requires separation of duties and change approval processes that prevent a single employee from unilaterally deploying code into production. This runs counter to the overall grain of DevOps. One of the core tenets of security is separating tasks across multiple employees to prevent abuse, fraud, or accidents. Now, this doesn't mean DevOps can't be used in these companies. It does mean special consideration must be given to compliance. DevOps is ultimately an evolution that removes barriers between development and operations. Like all agile frameworks and principles, each company must determine their appetite for which components and how much of DevOps makes sense for them. To explore DevOps further, I recommend the DevOps Handbook by Gene Kim and Jez Humble. Jez Humble pioneered the idea of continuous delivery, and as he noted in the book, DevOps is not a goal, but a never-ending process of continual improvement. This makes sense because the goal is to remove barriers, eliminate waste, and produce faster. And that's what the Agile movement is all about. Another recommendation is to watch the recorded seminar by Facebook employee Chuck Rossi. You'll get an idea of how a company like Facebook manages the power and risk of DevOps. Links to the book and the video conference are in the YouTube description.